Let's take a look at the Henderson-Hasselbalch equation. So the Henderson-Hasselbalch equation is commonly used in chemistry to calculate the pH of a solution. Now in chemistry, generally we'll use it to calculate the pH of a buffer. So the equation goes as follows. The pH is equal to pKa plus log of the concentration of the conjugate base divided by the concentration of the acid, and this is used when we have a weak acid. Then we also have the equation POH is equal to pKb plus log the concentration of the conjugate acid divided by the concentration of the base, and this is when we have a weak base. Now pKa is equal to minus log of the Ka value that's given. pKb is equal to minus log of the Kb value that's generally given. Now let's take a question and use the Henderson-Hasselbalch equation to solve it. So the question reads, a student adds 50 cm cubed of 0,250 moles per dm cubed butanoic acid to 50 cm cubed of 0,05 moles per dm cubed sodium hydroxide. A buffer solution forms. Calculate the pH of the buffer solution. The Ka of butanoic acid is 1.51 times 10 to the minus 5. So since we want to use the Henderson-Hasselbalch equation, we need to first figure out which one are we going to use. Is it going to be for a weak acid or is it going to be for a weak base? We know that sodium hydroxide is a strong base. So we are going to be using the equation pH equals pKa plus log the concentration of the conjugate base divided by the concentration of the acid. Now, let's first write out an equation to look at what's going on. So butanoic acid, I'm just going to write it as follows. I'm going to write it as HA. So the H represents the hydrogen that is going to be given off from the acid. And A is then the rest of the acid. That's going to react with NaOH to give us. Now remember, an acid will donate a proton, and so this hydrogen will be donated there, and you're going to form water, and you're going to be left with Na plus and the A minus. Right? Now what we're interested in is the conjugate base and the acid. So we're interested in simply this and this right here. Okay, so let's start. We've been given volume, we've been given concentration. Let's start by calculating number of moles. So for the acid, we were given the volume of 50 cm cubed, and we were given a concentration of 0,25 moles per dm cubed. We can calculate the number of moles. So number of moles equals C times V, 0,25 times 50 divided by 1,000, because it must be in dm cubed, and that's equal to 0,0125 moles. Now we'll repeat for NaOH. We've been given the volume is 50. We've been given a concentration of 0,05. We can calculate number of moles. So C times V again, 0,05 multiplied by 50 over 1,000, and that gives us 0,00 0.025 moles. Now, we need to evaluate. We can see that the number of moles of NaOH is lower than the number of moles of the acid. That means that the NaOH is the limiting reagent. And the amount of the conjugate base that forms is going to be dependent on the limiting reagent. Now, since the ratio here is 1 to 1, we can say that the number of moles of the conjugate base is going to equal 0.0025 moles. And let's remind ourselves that now the volume that this is in is going to be 50 plus 50. So the volume that this is in 100 cm cubed. So we're going to need this. Now we need to look at the amount of acid that's left over. So the amount of acid that's left after this reaction is going to be 0.0125 minus 0.0025, and that's 0.01 moles. But again, this is left over in 100 cm cubed. So from here we can get the concentration of the HA, we can get the concentration of the A minus. So to calculate the concentration here, we can say that concentration is equal to number of moles divided by volume. So 0.0025 divided by 100 divided by 1000, because we have to convert that to dm cubed. So that's 0.1, and that is 0.025 moles per dm cubed. And for the acid, it's going to be concentration is going to be 0.01 divided by 0.1, which is 0.1 moles per dm cubed. Now we have all the information that we need to use the Henderson-Hasselbalch equation to calculate the pH. So to calculate the pH, we're going to say pH is equal to pKa plus log, and we know the concentrations now. So the concentration of my conjugate base is going to be 0.025 divided by the concentration of my acid is 0.1, and we need to calculate the pKa value. So pKa is going to be minus log, and the Ka value that we were given is 1.51 times 10 to the minus 5. So 1.51 times 10 to the minus 5 plus log 0.025 divided by 0.1, and pH is then equal to 4.22. And that's it. Thanks so much for watching. Don't forget to like, share, and subscribe. I'll see you in the next one.